This is chapter 7. Once again, I'm with you. I'm your online lecturer for stats. We are going to look at random variables, and we will do the start. Random variables and discrete probability distributions. That is what we are looking at. Random variable. What is a random variable? A random variable is a function or rule that assigns a number to each outcome of an experiment. Alternatively, the value of a random variable is a numerical event. Instead of talking about the coin flipping event as heads and tails, we can think of it as 1 represent head and 0 represent tails. So that set would be 1, 0. There are two types of random variables. There's a discrete random variable, one that takes on countable number of values, example, values on the roll of a dice, 1, 2, 3, 4, blah, 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 12. Continuous random variables, one whose values are not discrete, not countable. Example, time, 30.1 minutes, 30.1000001 minutes, and so forth. And the analogy is integers are discrete while real numbers are continuous. Probability distributions. A probability distribution is a table, a formula, or graph that describes the values of a random variable and the probability associated with these values. Since we are describing random variable, which can be discrete or continuous, we have two types of probability distributions. Discrete probability distribution, this chapter, and continuous probability distribution is in chapter 8. The probability notation, an uppercase letter will represent the name of the random variable, usually x. Its lowercase counterpart will represent the value of the random variable. The probability that the random variable x will be equal to little x is written as probability of x equals x, or simply p of little x. Discrete probability distribution. The probabilities of the values of a discrete random variable may be derived by means of probability tools such as tree diagrams or by applying one of the definitions of probability, so long as these two conditions apply. 1. The probability of x lies between 0 and 1 inclusive for all x. 2. The sum of the probabilities for all x must be 1. The sum of the probabilities must add up to 1. Those two rules must obtain. Here we have an example where we've got a table showing television receivers and the households and the probability of finding a given household with no TV sets or one TV set or two accordingly. This table represents the probability distribution. Example, the probability that x is equal to 4, that is, that a household has 4 TV sets, is given by P of 4 equals 0.076 as shown. What is the probability there's at least one television set, but no more than 3 in any given household? You have to translate that into math notation. It's written as this: the probability that x is greater than or equal to 1 and less than or equal to 3 would include summing the probabilities x is equal to 1, x is equal to 2, and 3. So you add in probability when x is equal to 1 plus the probability x is equal to 2 plus the probability when x is equal to 3, and that gives you, from the table, 0.884. Developing the probability distribution. Probability calculation techniques can be used to develop probability distributions. For example, a mutual fund salesperson knows that there is a 20% chance of closing a sale on each call she makes. What is the probability distribution of the number of sales if she plans to call 3 customers? Let S denote the success. That is, closing a sale, probability of closing a sale equals 0.2, probability of not closing a sale is 0.8. And we develop a tree diagram as shown there. In this case, we are going to skip. Tree diagrams are not included in this course at this time. So we will go further down. Population probability distribution. The discrete probability distribution represents a population. Example 7.1, the population of the number of TVs per household. Example 2, the population of sales call outcomes. Since we have populations, we can describe them by computing various parameters. Example, the population mean and the population variance. The population mean, or the expected value, is the weighted average of all of its values. The weights are the probabilities. This parameter is also called the expected value of x and is represented by E of x as shown. E of x is equal to the mean, population mean, is given by the sum of all x's of x times p of x. Sum of xi times p of xi. That is the x value times its corresponding probability. These products are added for all x. Population variance. A population variance is calculated similarly. It is the weighted average of the squared deviations from the mean. Shown here, V of x, the variance, is equal to sigma squared, the variance, is equal to the sum of x minus mu squared, the deviation squared times the probability of x. This is for all x's. The shortened form, the shortcut formulation looks like this. V of x equals sigma of x squared, which is equal to the sum of x squared times p of x for all x minus mu squared, minus the mean squared. So you would square each x value, multiply by the corresponding probability, sum all those products, then subtract the squared mu from that result. That gives you the variance, population variance. The square root of the variance simply gives you the standard deviation, as shown. Applying these to the formula would give you this. This is x, p of x. For example, it would be, as shown here, sum of x p of x is equal to 0 times p of 0, right down to 5 times p of 5. That gives you 2.084, as shown. Calculating the variance using the long form is x minus mu squared times p of x for all x. The example here is 0 minus 2.084 squared times 0.012. That is for x1 minus the mean squared times the probability of x1. Then the same is repeated for x equals 1 right down to x equals 5. The result gives you 1.107. The square root of that gives you the standard deviation, which is 1.052. Laws of expected value, you are not required to to memorize that or learn that at this time. And we'll pass that on. Laws of the variance, that's also excluded at this time. The binomial distribution. Binomial distribution is a probability distribution that results from doing a binomial experiment. Binomial experiments have the following properties. 1. There are a fixed number of trials represented as n. 2. Each trial has two possible outcomes, hence the term bi, a success and a failure. 3. The probability of success we can denote by p, little p, and thus the probability of failure is 1 minus p for all trials. 4. The trials are independent, which means that the outcome of one trial does not affect the outcomes of other trials. Success and failure are just labels for binomial experiment. There is no value judgment implied. For example, a coin flip will result in either heads or tails. If we define heads as success, then necessarily tails is considered a failure, inasmuch as we are attempting to have the coin land heads up. Other binomial experiment notions are an election candidate who wins or loses, an employee is male or female. Random variable binomial experiment is defined as the number of successes in n trials and is called the binomial random variable. Example, flip a fake coin 10 times. 1. The fixed number of trials, n is equal to 10. Check. Each trial has two possible outcomes, heads, success, tails, failure. Check. Probability of success is 0.5, probability of failure is 1 minus 0.50, which is also 0.5. Check. The trials are independent. The outcomes of heads on the first flip will have no impact on subsequent coin flips. Check. So all 4 are checked out. Hence, flipping a coin 10 times is a binomial experiment since all conditions were met. Binomial random variable. The binomial random variable counts the number of successes in n trials of the binomial experiment. It can, on values from 0, 1, 2 to n, thus it's a discrete random variable. To calculate the probability associated with each value, we use combinatorics. This is shown in the formula here. The probability that x equals little x is given by n factorial over x factorial times n minus x factorial, and p to the power x times 1 minus p to the power n minus x, where x is equal to 0, 1 to n. This is a formula for calculating the probability that x takes on some value. Pat starts out is not a good student. Taking a statistics course, Pat's exam strategy is to rely on luck for the next quiz. The quiz consists of 10 multiple choice questions. Each question has 5 possible answers, only one of which is correct. And Pat plans to guess the answer to each question. What is the probability that Pat gets no answers correct? What is the probability that Pat gets 2 answers correct? Pat starts out not a good student taking statistics course whose exam strategy is to rely on luck for the next quiz. The quiz consists of 10 multiple choice questions. Each question has 5 possible answers, only one is correct. Pat plans to guess the answer to each question. Algebraically then, n is equal to 10. The probability of success is 1 over 5, which is 0.2. The probability of guessing a correct answer is 1 over 5, which is 0.2. Little p is 0.2. Pat starts that again.